Good day and hi everyone, my name is Warity Devera and today we'll be solving the circles and other geometric figures on coordinate plane. The circles and other geometric figures on the coordinate plane, presented by me. So in this video, we must graph a circle and other geometric figures on the coordinate plane and solve problems involving circles and other geometric figures. So when graphing a circle, first we must know the equation of the circle. The standard form equation with center at the origin is x squared plus y squared is equals to r. The standard form equation with center at hk is x minus h squared plus y minus k squared is equals to r squared. And the general form equation is x squared plus y squared plus ax plus by plus c is equals to 0. Second, we must determine the circle and the radius of the circle. And lastly, we will plot the center of the circle on the coordinate plane. So first example, sketch the graph of the circle defined by the equation x squared plus y squared is equals to 25. So first step, we must determine the center and the radius. So the center is at point 0, 0 and the radius is square root of 25 and is equals to 5. The equation we use is the standard form with the center at the origin x squared plus y squared is equals to r squared. So the second step is we must construct a coordinate plane, then plot the center which at point 0, 0 and label it as point C. Plot the radius points. The radius points are located using the radius from the center. Extend the length of the radius in 4 directions: right, left, right, up, and down. Since the radius is 5 units and the center has coordinates 0, 0, 5 radius points could be obtained by counting 5 units to the left from point 0, 0 or subtracting 5 from x coordinate and carry the y coordinate at the center. We let this radius point as a. The coordinates of a is negative 5, 0. Next, counting units to the right from 0, 0 or adding 5 from the x coordinate and carry the y coordinate at the center. So we let this radius points as b. The coordinates of b is 5, 0. Next, counting 5 units upward from 0, 0 or adding 5 from the y coordinate of the center and carry the x coordinate of the center. We let this radius point as d and the coordinates of d is 0, 5. Next, counting 5 units downward from 0, 0 or subtracting 5 from the y coordinate of the center and carry the coordinate of the center. We let this radius point as e. The coordinates of e is 0, negative 5. So we will graph it using the GeoGebra app. So by using the sphere, center, and its radius. Point is at the center, so we will now input the radius end of the circle. Yeah. So the radius of the circle is 5. As you can see here that the radius is at the radius is at 0, 5, 0, negative 5, 5, 0, and negative 5, 0. This is the circle. For our third example, a triangle has vertices s, negative 2, 5, u, 3, 8, and n, 8, 5. find the area of the triangle. So the first step that we will do is illustrate the given. So the first point is -2 and +5. So point. So I think +5 is here, so let's point it. Now let's try another one. I think this is okay. The next point is +3 and 8. Next. So the next point is at +8 and +5. Let's try another one. Yeah. We will now solve the area of the triangle. So the area of the triangle is 1/2 base times height. So base and height of a triangle can be identified by counting the numbers of units as shown in the illustration. So as you can see here in illustration, the base has 10 units, the height has 3 units. So let's check it in. So the units of the base is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the unit of the height is 1, 2, 3. So next, solve the area of the triangle. So the area of the triangle is 1/2 times 10 times 3 is equal to 15 units squared. The area of the triangle is 15 square units. And that is the end of our discussion. Thank you for listening and have a good day, everyone.